All right, good morning, geometry, or good afternoon. This is third period. I'm out because I've got a sick kid and then another kid whose preschool is closed today because the person running the preschool is sick. So a lot of bugs going around. Hopefully you guys are feeling well. Um, I'm going to walk you through what I need you to do today, and it's all connected to the idea of slope. I was going to do more than one thing today, kind of like in little smaller steps, but because I'm out, I want to just have a narrow focus so that you can just focus on that one concept for the whole day. So I've printed out, and it's on the table up here. There's two documents that you will need for today. One is the slope worksheet. And as I've said before, if something is a separate sheet of paper, that means this won't go in the gradebook. But you need to know how to do this to do the part of the project, which brings me to the other sheet you need, which is your airplane, ideally with all of the coordinates already written on it. You've been given lots of time to do it in class, lots of resources here, so this needs to happen. Like, we can't do the project without it. So I have put first and third period airplanes up there, but I also have a pile that's up here on my teacher desk that is like planes that aren't claimed, like they don't have a name on them. And you're welcome to claim one if you forgot to write your name on one, or if you just don't have one, you're welcome to claim one rather than starting completely from scratch. Just make sure that whatever plane you claim, it should have some sort of right angle somewhere in the middle-ish of the page, not dead center. It could even be up here, that's fine. Just somewhere in the middle, having a right angle crosshair, super helpful for creating these coordinate grids. I am not going to talk about how to do all this. That actually might be in a previous video. I will actually go over it just briefly at the end of this video, but I don't want to focus on this right now. I want to focus on what is new today. And so let's start here with the worksheet. Okay. So I don't even have your workbooks here, again, because I don't want to overcomplicate things. So I just want everything on this worksheet and on your airplane. Okay. So we're talking about slope. And the definition of slope is the amount something goes up and down versus how far it goes side to side. So the words that we use in mathematics is rise. Rise is an up or down, because the sun rises, but it can actually go down. And when we talk about rise, we can have a negative rise, which would be going down, and then run, which would be side to side, because that when you run, you don't run straight up in the air. So, and so that's the language. And it's just basically at its core, it's just a counting exercise. So let me show you on these first problems. This first sheet here, it's got 8 problems. Let's do the first 2 together, and then you can do the rest. Okay, so, also, the letter we use to represent slope is the letter M. I actually don't know why. You can look it up. I don't know why we use the letter M. Okay, it might be because it was like something in a different language other than English. Oftentimes when the letter doesn't make sense, it has to do with the discovery or the mathematician being someone who spoke a different language. Okay, so here we go. We've got, we can pick any dots on these, on a line to determine the slope, but they've kind of made it easy for us by like drawing in some clear intersection points. And so all you're going to need to do is going to need to count your rise and your run. So here we go. So on top, I need to write my rise, and on bottom, I need to write my run. So you start with the point on the left. I think this is the easiest way to do it. If you do it with the one on the right, then you got to think in these kind of like convoluted backwards terms. So you start with the one on the left, and then you count how far you went to the right. 1, 2, 3. So that would be my run, 3. Okay. So run is sideways. So if I just count how far I went, 1, 2, 3, and then how far did I go down? I went down 1. And down is a negative. So my slope is a negative 1/3. So that's my slope. That's what M is here. Okay. So again, my run was 3 because it counted 1, 2, 3, and I went down 1, so that's negative 1 over 3. Negative 1 over 3. It means I went down 1 when I went right 3. Okay? Okay, let's show that again. Let's go here. Here's the 2 dots that it's given us. We can actually choose other dots. If I wanted to use these 2 dots, I certainly can. But I'm going to use these ones, okay? As long as you're accurate, it doesn't matter. So here we go. Our slope is rise over run. And so again, I start with the left one. Sorry, actually, these 2 dots, that's the left one. And how far do I go left to right? I go right 1. Okay, right 1. And then it looks like I go up 1, 2, 3. And it's positive because I'm going up. So it's positive 3. And this is the correct starting point. But whenever you can simplify in mathematics, we simplify. 3 divided by 1 is just 3. So this is a slope of 3. Okay? And so I want you to pause the video here. And all I want you to do is calculate the slope of the other lines. And you can check your work. There's an answer key stuck to the whiteboard. And you can check your work if you're kind of waiting or before you move on to the next one. Okay? All right, I'm going to pause it here. You go ahead and do that. Okay, hopefully you've done all that and checked it. Made sure you understood that, because now we're going to get into the point where rather than giving us a graph, we're just going to give us a set of coordinate points. And from there, we're going to use what's called a slope formula, which is basically plug in the numbers here properly into the slope formula, and it can calculate the slope between any 2 points. And like we've seen before in the midpoint formula, that anytime you see a y2, y1, x2, x1, this just means that we're referring to 2 different points. There's point 1, point 2. And so for the sake of simplicity, let's just call our first point, point number 1, and our second point, point number 2, every time. Okay, the one on the left is 1, one on the right is 2. And so how I would label this is x1 would be that first x coordinate, and x2 would be the second x coordinate. And then y1 would be the first y coordinate, and y2 would be the second y coordinate. So this is true every time. So every time you see it, you can go x1, y1, x2, y2, x1, y1, x2, y2. If you just hold that pattern, it works every time. You technically can reverse it, meaning you can call this point number 1 and this point number 2, still get the same answer. But for the sake of simplicity, let's just use the same format each time. And then we go ahead and just plug those things into the formula. Now, I'm going to do the first 2 here, and I want you to follow along and do it with me. Okay? So the top says I take the second y and subtract the first one. So the second y here, and I'm going to zoom in. The second y here is 14. So I'm going to take 14, and I'm going to subtract the first y, which is 10. 10. And then it says take the second x. Second x is negative 7. And subtract the first x. So minus 8. That's the first x. Okay? And then we just have to do the simplification. So 14 minus 10 is 4. And negative 7 minus 8. So here's a little bit of a, I don't know if this helps you at all. We're going to find out. Okay, a little tangent here. So if I go 7 plus 8, that's the same as saying positive 7 plus 8. So I'm just going to make it more explicit here. I get 15. If I go 8 minus 7, I get 1. Okay, these are things you learn like really early on. But we just don't write that positive symbol there. But there's also a positive symbol there. We just don't write it. So note here that when both of the symbols were the same, the total was the sum of those 2 numbers. Versus when the signs are different, the total, when you put them together, is the difference of those 2 numbers. So the same is true if you just reverse it and you have negative 8 plus 7, or negative 7 minus 8. Okay, so all I've done is taken the same exact thing, and I've just reversed those numbers. Okay, so sorry, reverse their signs, positive, negative, negative, positive. So in this case, the answer is -1, because I still am finding the difference. They're different signs, so the difference between 7 and 8 is 1. And the only reason this is negative is because -8 is the larger value. So if I take -8 and I move over 7 units, I don't get into the positive territory. I'm still in the negative territory, but it's still a 1, because when the signs are opposite, we find the difference. So in this case, I end up getting -15, because if I start at -7 and get even more negative, that means that I'm going to get farther from 0, so my value is going to increase, but it's going to go in the negative direction. So just a quick recap. When you're combining numbers through addition and subtraction, if the signs are the same, the values are you're going to find a sum, regardless whether it's positive or negative. The only change is this is a positive sum, this is a negative sum. And then over here, when the signs are opposite, you find the difference. The difference between 8 and 7 is 1. The only difference is that in this case, the positive number is bigger, so I got a positive answer. And in this case, the negative number is bigger, so I got a negative answer. Okay, so coming back from that little aside, okay. So -7 minus 8 is, still the camera, -15. Okay, as you saw earlier, that's not enough. We need to simplify. So now I need to remind you that if you have a positive divided by a positive, you get a positive. If you have a negative divided by a negative, you also get a positive, because you do the opposite of a negative, so back to positive. Okay. But when the signs are opposite, a positive divided by a negative, I get a negative answer. So the answer to this one is -4/15. So in other words, I don't write 4 divided by -15. I write -4/15, because the whole answer is negative, so I just move that negative out front. Okay. If it was -4 over -15, well, then that would be +4/15. Okay, and that's it. That's the sum. All right, let's do that again. Okay, again, it's the second y, 2, minus the first y, 1. Okay, and then it is the second y, and it's the second x, -17, minus the first x, which is -3. Well, what happens when you subtract a negative? When you subtract a negative, you add. So I get +13. Okay? And that gives me 2 minus 1 is 1. And on the bottom, the signs are opposite. That's a negative, that's a positive. So I find the difference. The difference between those two is 14. And because this is the bigger one, it ends up being -14. So similar thing as over here. Now I just need to go, that's a positive divided by a negative. My answer is -1/14. Okay. And that's all you need to do. I do want to note one thing, and that is if you come across a scenario, say like you get, I'm just going to make one up here, say you get to this spot. Well, first, a negative by negative is a positive, so that's just 4/10. But then the other thing is if a number will go into the top and to the bottom, then you should simplify it. So these are both even numbers, so that means 2 goes into both of them. So you just divide the top by 2 and the bottom by 2, which if you do the top and the bottom by the same number, you aren't changing the overall value. So 4 divided by 2 is 2, and 10 divided by 2 is 5. And this would be the simplified version of that slope. Okay? And so that's it. That's the whole process. So make sure that you ask questions if you get stuck on this, or go back and watch the video again. But all you are doing is every time you're taking the second y coordinate and subtracting the first y coordinate, and then taking the second x coordinate, subtracting the first x coordinate, and putting those results in a fraction like this, and simplifying. That's it. Okay. I'm going to pause the video here, and you should as well. And then the next thing to do is how to do that on your airplane. All right. Okay, hopefully you have completed problems 1 through 16 on the slope worksheet. You do not need to do problems 17 and beyond on the slope worksheet. and you've checked your work. Again, the answer key is on the whiteboard, held up there by a magnet thing. If you've done all that, then you're ready to do it on the airplane. If you have not done all that, please practice the slope. Make sure you're doing it correctly. Okay. Now, for the project, for the airplane, we are going to write the equations of all of the lines, and that means finding the slope of all of the lines that are, of all the lines, but primarily the ones we need to calculate are the ones that are diagonal. Ones that are vertical or horizontal, we don't actually need to use the slope formula. I'll teach you that to you later, but for today, all you need to worry about the ones that are not perfectly horizontal or vertical, those ones we need to calculate. So you can see a couple, like that's obviously a diagonal one, but it might not be as obvious at first, but when you look, you can see that this is not straight up, so that's at an angle, and so is that, okay? And so those would be ones that I need to calculate the slope for. And so on this drawing here, it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 total lines to find the slope. So I'm going to show you how to do that. To give you the gist of it is you're just going to use the slope formula again, but now we've got these mixed numbers. And that's not something you want to do on paper. And so for this reason, we're going to move to Desmos. But in order to do this right, I'm going to try to see if I can do a weird split screen here. Not weird split screen, just a split screen to help us so you can see what I'm doing on the paper and also what I'm doing on give me a moment here. And then this is not going as fast as I thought it would. I'm sorry, I'm trying to do this on the here. I'm going to pause the video. So, okay, I got something to figure out finally. So here I've got my paper, and here I've got Desmos loaded up. So you go to desmos.com, and you're going to scroll down, and you can go ahead and click the scientific calculator. Okay. And then when we get into here, what we immediately want to do is hit the divide button on our keyboard so that it creates, as soon as we hit the divide button, it creates a fraction because remember the slope formula is a fraction. So we're just going to use the slope formula, but we're going to do it in Desmos because it's just going to do a faster, better job, especially with mixed numbers. So for this example, I'm going to do point C and point G. I'm going to find the slope of that line, and then I'm going to write it down on here so that I have it on my airplane for later when we go to model it. Okay. And to do so, I need to take the y-coordinate from the second one, so I'll call this the first one, and this is the second one, the y-coordinate of the first one, and subtract the y-coordinate of the second one. So that's taking 4 3/8 and subtracting 1 7/32. Okay, so I'm going to go 4 space 3 divided by 8, arrow over, minus 1. Oh, and by the way, no, that's correct. I did it right. 1 space 7/32. So there's the top. I just did that y-coordinate minus that y-coordinate. Okay. I'm going to move to the bottom, and I'm going to go that x-coordinate, which, well, conveniently that's 0, minus, and then I notice that this is a negative, so if I'm going to subtract a negative, I think if I type minus twice, Desmos will do it right, but don't do that. Type plus. Subtracting a negative is adding. And then I'm going to write 3 space 1 over 16. Okay? And like before, we can turn this into a fraction. And that weird number, that weird fraction, is our slope. It's a rise of 101 and a run of 98. That's almost a perfect, we haven't gone over these properties, that was pretty close to a perfect 45-degree angle, which if I had folded this perfectly and measured it perfectly, I think that's what it would have come out to be. but I didn't do those things perfectly, and so it's just a little bit off. So all I'm going to do on my paper is I'm going to write right here along this line, m is equal to 101 over 98. And I'm making sure to write it at an angle so that I know that it's referring to the slope of that line. And so that's all I want you to do to finish up on your airplane. Find all the lines that are not either straight up or straight sideways, anything that's diagonal, even just a little bit, and calculate its slope. And use Desmos to do so, because trying to do that thing by hand is a nightmare. And that's it. That's all I have for you today. This, remember, this airplane is the summative piece. And so finishing this and getting those slope pieces in is a critical step to finishing out our project, where we're going to model our airplane and write equations to model the entire thing. Okay? And hopefully I will see you tomorrow.